Next, we have a talk from Benjamin Van der Veen, as partner at Portland-based software design and development house at Servant James, boasting 15 years worth of software design and delivery experience, as well as a healthy interest in no-holds-barred bike riding and flying small planes in his downtime. Benjamin's here to talk to us about mobile development with less complexity, more confidence, fewer manual steps.
Thanks, Simon. My name is Benjamin Van der Veen. I'm going to be giving a talk about mobile development. The inspiration for this talk is kind of largely based on my experience running about an 18-month project on a team of about 10 mobile engineers to build out a pretty complex application for a startup. If you have questions, feel free to heckle me. It'll make it more interesting. So a little bit about me. I used to be an archaeologist, but frankly, my life was in ruins. So I made the jump to software. Started mobile development around iOS 2 when that first iPhone came out in 2008. Before that, I did a lot of web development, starting sometime back in 2000. I've made web apps and API services in just about every language and framework that's been in widespread use for the past 15 years. Prior to mobile interfaces, I also did a lot of Flash stuff, Windows and Java desktop apps. Lots of experience with low-level networking and I/O stuff. All this to say, trust me when I say mobile development's pretty hard. It's harder than web apps and services, I think. There's a lot of application state to manage, a lot of events to respond to for a given application state, lots of subtle UI details to account for. The automated testing story, from where I stand, isn't as clear or as well developed as it is with web applications and services, and same thing with deployment. It's pretty complex and tedious with a lot of manual steps, especially on iOS. So since the iPhone first came out, we got a lot more people developing, a lot more domain knowledge, more libraries, more dependencies, more device processing power, memory, network bandwidth. More visual designers. There's just like a lot more people playing in the sandbox than there were 8 years ago. And there's just a lot of stuff going on, and as mobile development teams, our work is being compared to really well-funded teams at big companies. And users' expectations of design and user experience are way, way up. And there's a lot of pressure for us to deliver really beautiful, whiz-bang, unique-looking software. And designers play a really important role in this, but one of my theses here is that they're kind of uniquely positioned to torpedo mobile development projects in subtle and interesting ways, especially when the project budget is less than the GDP of a small country, which some big companies actually have that luxury to have those kind of big budgets. About automated testing and deployments, still kind of uncommon from where I'm standing. Most mobile code bases I encounter don't have tests. Most mobile engineers I encounter don't have experience writing tests. And deployment automation in mobile is still almost unheard of and really hard, arguably impossible in some cases to achieve. So what are we going to do? Some of this isn't going to be a big surprise to like you guys at a testing conference. Obviously, run automated tests, run a manual test plan, automate deployment as much as possible. And one of the things I'm going to kind of spend some time on is looking into how we can allow the platform to kind of shuttle us into easy to implement and expedient UI and UX solutions. And that's going to save us a lot of headache. So we'll just start with automated tests. What are we supposed to test in mobile apps? Compare web apps. In web apps, it's pretty much figured out. Like we have input. When I submit this form, do the expected records get created in the database? Output, given that there's some data in the database, when I look at my page, then it should show me the things that I expect to see given that data. And then validations, right? If I put some bogus data in this form or in a query, does it give me an error that makes sense? And integration tests, which we've, Rebecca talked a lot about in her talk earlier this morning, clicking around the web app and like making sure that it shows the right things and that users can carry out key user stories. It's kind of like smoke testing. Mobile apps, less often, they don't often have forms. There's kind of like less in common with web apps in terms of what's testable. More frequently, there's sort of a layer of functionality on top of a system that looks a lot like a traditional web application or a web service, and indeed, they often have dependencies on those. And so, whatever backend your mobile app is talking to, it probably already has a huge number of tests covering those things, and we're not necessarily trying to duplicate the tests that the backend already has. But mobile apps have a lot of other stuff going on. There's really complex visual aspects in a mobile app, complex user flows. There's dependencies on real-world external services like location services, push notifications, the user's contacts, calendars, your own web service backend, and other like third-party web services that you might depend on. So we can write tests around some of this stuff, but probably not all of it. Probably doesn't make sense to write tests around all of it. So, one of my operating philosophies is let's stay away from testing all the visual stuff. Let's just avoid testing for visual behavior. So this would be like text and image layout. If we, tap a button, does it turn the expected color? When we, scroll this thing up, does like the top bar get smaller or whatever? Making these interfaces is often like more art than science in my experience, and doing a lot of testing around this is like either not practical or wouldn't really give us strong guarantees. It would take really long to do. It might also be really hard to maintain that test suite, especially as the UI changes. Someone who is used to wielding like a far larger budget and longer timelines than I am could probably argue against me on this point, and I would roll over. But I think most of us are going to have the experience, and like Tom kind of pointed out, it's like you got to prioritize what you're going to do. And for me, testing this visual stuff is pretty far down the list when we're really trying to deliver business value. So I say test everything that isn't the UI. Make a backend module. Code is tested if and only if it's in that module. So if it's tested, it's in there, and if it's in there, it's tested. And make sure that backend module doesn't link against UIKit or the Android.view package. Like it should be completely agnostic of presentation layer code. It's like plain old Java objects, pure Swift or Objective-C, nothing that's taking a dependency on the UI framework. Another really useful tactic that I found is to like mock out some of those system services and write automated tests around your code that interacts with those services. So that would be things like the user's contacts, like any kind of permissions dialog, push notifications, that sort of thing. Because it can be extremely tedious and sometimes impossible to get the real system to trigger the behaviors you want for all, in manual testing for all the cases that you'd want. So like, kind of the classic example is getting that on iOS. There's that, do you want this app to allow push notifications dialog? It turns out that you can only get that dialog to come up once for an app on a given phone. And in order, even if you delete that app, it won't show that dialog again. And you'd have to do actually a factory hard reset on the phone to get that dialog to come up again. And you really don't want that in your testing loop. But at the same time, it's really reasonable to want to have some sort of test where it's like if the user says yes to this permission, that the app does one thing. If the user says no to that dialog, that it does something else. And how can we avoid the pain of having to reset the phone in the midst of that? Okay, this is kind of like this is a big subject area. It could be a talk on its own. I'm not going to spend too much time here. But if state machines mean anything to you, if you have like CS background, I found this is like a really fruitful way to model your application and to test it. Basically, we model all the inputs that an application could receive as events or like tokens that you would feed to a state machine, and then all of the things that the app would do as like side effects or output from the state machine. So an example of an input event would be like the user logged in, a web service returned such and such data, a notification was received, that sort of thing. And examples of output would be prompt the user to log in, ask the user for their security PIN, display an error, or like display the sensitive data to an authorized user. So you could imagine kind of constructing a state machine around this. Just a really simple example. It's like almost a throwaway, but given the following input events, like the app starts and we read the flag of has the app started before, and it's not set. Assert that the application displays the first run screen and then sets that flag. You can pretty easily imagine like writing a test around this. And then for things like it would be like more complicated examples, like if some action that you want to take inside the program requires that the user satisfies like 3 dependencies, but they could have done it in any order. No. Interpellated, okay. You would want to test that like you can do those things in any order and that the app still does the right thing. Talk to me about that if you want to hear me yell about state machines later. So recap, where are we at? Create a backend module. Everything that's in there has an automated test. Everything that has an automated test is in there, and it's completely agnostic of UI. So you can boot this thing up. It's like a jar or like a Swift core library or whatever that you don't need to run even in the simulator necessarily. You could run it, on your Mac in a regular Java thing. It doesn't know anything about Android system or iOS's UI. Mock out system services. Use state machines where possible, where it makes sense, and don't write automated tests for UI stuff. Okay, manual testing. Again, everyone's probably going to be pretty familiar with this, but I'm going to say manually test everything that's not covered by your automated tests. And what is that? That's all that layout and rendering code we talked about. There's kind of only one way to test that stuff, is to boot up the app, look at it, browse around, and like make sure that things look right. Like that really awesome onboarding flow that the UX people put together, making sure that that performs nicely and that it looks the right way across like different device sizes. In order to get them to sign off on that going out to production, you're going to need to put it in their hands and they're going to need to play with it. There's kind of only one way to test that stuff. Integration with web services, again, Tom talked about this. Performance is really important. You need to know that like the version of your protocol that your services are speaking or works with like the current version of the app. You got backwards compatibility issues in there potentially. Got to test that manually. Again, it's one of those things you could probably automate it given enough time and budget. Other things like real world requirements. If I'm out like walking around, it's Pokemon Go or like Strava or something. Does it do the right thing as I'm interacting with the real world? That's something you kind of need to go outside and test manually. And then adequate performance. You can kind of like, make sure that the app is like rendering fast and that sort of thing. But in a lot of cases, again, like Tom already made this point in his talk, who knows, like if you're far away from the Wi-Fi access point or like there's, you're at a festival and the network's overloaded, all these kind of things. There's only one way to test them. So kind of my key thing that I'm going to say about manual testing that's like worked really well for us is keep the testing plan in your source code repo and update it along with your app. So treat it like source code. It goes, when you make a feature branch, you do a bunch of commits, to implement a new feature or whatever. The manual test plan needs to be updated along with that, so that in addition to running your automated tests, you can run through that manual test plan, see that the application is still correct, insofar as tests can tell us that sort of thing, before you merge it, and then after a merge, run it on master before you do a release. And for us, we've gotten really good mileage out of making this a part of code review, so that like the engineering team can sort of like have a little bit of ownership over that testing process and be like, hey, maybe you could rewrite this, or like the way that you put this would maybe make more sense if we kind of, whatever kind of copy edits or something like that. And just kind of like treat it like source code. Treat it like you would treat your tests. And again, ideally we would run it exhaustively on a feature branch before you merge that feature into master. You would run it on master before or after a feature merge, and then run it before every release. And again, as we know, like these test plans can get like really long and really detailed. So sometimes we need to kind of maybe cut some corners on that. Kind of depends on your use cases. But again, we're kind of going to use our judgment when we're thinking about like how complex our manual test plan is versus like how much time we have to spend running through it. Maybe you just run things that you are pretty sure changed. Maybe there's like areas of your app that you like know are really stable. Maybe there's other areas of your app that like we definitely don't want to ship a bug here, so we're going to run this every time anyway. Kind of up to you. But again, the idea is that we've gotten great mileage out of treating the test plan like source code or tests from a process and methodology and development standpoint. Again, it gets updated in lockstep with the application. It's a test, so it's ran as often as possible to catch regressions, and we're disciplined about updating it and running it. And we recognize that there's nothing worse than broken tests that haven't been run in ages, and so we really try and avoid that situation. All right, so recap. Mobile is hard. Do automated tests, do manual tests. So far, not a lot of controversy at a testing conference. And this is where I'm going to start kind of sounding like a lunatic a little bit. But we'll start from a good shared premise. MVP, I think we all know what this means. LeWitt gives the definition: simplest possible product that allows you to validate your market hypothesis and allows you to learn enough to iterate the product forward. Market hypothesis. That's kind of like a business word. That implies that we're trying to do some business stuff. We're really focusing on business value, is like kind of like what we're all ultimately doing, is trying to deliver business value. It's hard enough to ship correct software, and it's even harder if you're trying to reinvent how users interact with their devices and the entire look and feel of their operating system. Designers, from time to time, like to invent completely novel interaction paradigms, and you ain't gonna need it. Focus on your business goals. Apple and Google have spent a lot of time putting together components that are going to be familiar to users, that kind of like make the system make sense. They've put a lot of thought both from the user experience standpoint as well as the developer experience standpoint to how those components fit together. And we should really be leveraging those as much as possible and not trying to reinvent the wheel. So the section isn't so much meant to pick on designers as it is kind of like a cautionary tale to everyone involved, whether you're a developer, designer, tester, project manager, or anyone else sort of further up the food chain wondering why this stuff is so hard. And this is a really tough problem. How do we address the tension between what's possible sort of in Photoshop and what code actually gets written? It intersects with organizational politics. It has long-term implications for how responsive the product and engineering team can be to the business. And it has pretty far-reaching implications on the ultimate quality and usability of the software. So just like really simple example, you ask iOS for a button, you just basically get some blue text. If the designer comes by and says that they want it to have a border and a gradient, and when you tap on it, it turns green or something like that, it's kind of like, on one hand, 1 line of code, 1 second, 1 minute of development time. On the other, perhaps 20 lines of code back and forth between design and development. And it doesn't seem like very much. It is only 20 lines of code, like whatever, these people have to talk to each other anyway, but this kind of thing can stack up. Another really kind of like a deeper example. Let's imagine that we're making an app. Let's take Airbnb, for example. We want to allow users who are not registered, they just downloaded the app from the App Store, to be able to like browse listings, have a great experience, see everything. And then they scroll to the bottom of that great vacation place and they click book this. Now, we don't know who this user is, and we wanted them to be able to find this thing, so we're going to put them through this kind of like intermediate step of like get registered, put in your credit card information and all that sort of thing. And then when they're done with that step, they're going to go into the actual booking flow that they would have experienced if they had already been signed up on the platform. They would have just seen that immediately. So like, let's kind of imagine 2 ways that you could do this. The first is like the standard iOS. You're looking at the screen, you click that, Airbnb, book this thing. It slides up, you go through onboarding, and when that's done, it slides back down, and then you're in the booking flow. Versus, you click that button, and then the screen slides over in like a drill down navigation. You go through that onboarding flow, and then it slides over again to the booking flow. It seems like a really subtle difference, but I can tell you from experience that the former is like really easy to implement, like 10 lines of code, and the latter is really, really difficult, maybe impossible in some cases, depending on what the dependency graph is. And if you try and mix those two paradigms in one application, it's like 10 times as complicated as just doing option number 2. But these are really subtle differences. Like, the designer almost certainly has no idea of the relative implementation complexity of these 2 design decisions at the time the decision is made. So what are we going to do? We need to make the designer somehow aware of these constraints. in order for them to be able to make the right decisions. Like to say software engineering is a mill and a lathe rather than a 3D printer. Just because a designer can imagine a part doesn't mean that it's possible to bring it into reality given the tools available to us. There are some shapes a lathe operator just can't make, and we need to be able to communicate about that. So we're going to go just a couple of scenarios about like how this process might play out in an organization, and I kind of identified two sort of pedagogical modes. The first one is pitch it over the fence. The designer designs a feature, the developer spends some amount of time on the feature. The developer may or may not have achieved the designer's vision in that time. If the vision's achieved, great, we move on to the next thing. If the vision is not achieved, we need to spend more time, or we need to like abandon or change the vision. If we spend more time, we sort of just like go back to step one. If we need to abandon or change the vision, maybe time has been wasted here, maybe people are frustrated, like trust might be frayed. That, you know, that was like a big core principle of Rebecca's talk, and I think trust is like really important. And more importantly, from the business standpoint, like did we miss deadlines or opportunities while we were down here in the weeds arguing about what color this button is? So the second mode is, well, okay, we'll go back to this one real quick. The key thing here is that there's no feedback to the designer regarding the implementation complexity until that cost has already been incurred. In mode 2, which I'll call collaboration, the developer is able to raise red flags and can kind of help steer the product design to a more technically expedient solution. You know, again, the goal is for the designer to have a sense for how much a feature design is going to cost from a technical perspective before that cost is incurred. And again, with better information, the product team can make better decisions. So we really need that functioning feedback loop between the UX people and the development people in order to execute as efficiently as possible. And this has implications for the business relationships between everyone as well. I've kind of, in my career, I've done contracting stuff, I've done salary stuff, I've kind of been on both sides of all those tables. And if like design and development, if one side is on salary and the other's a contractor, you can kind of have conflicts of interest there. If both sides are contractors, especially if you have design from one firm over here and development from another firm over here, you know, they can really have misaligned incentives. And even if they're both on salary at the company, if they're perhaps like siloed on opposite sides of the org, you know, you got to look into the organizational history of why that is. Like, do these separate sides of the organization already trust each other? Have they been button heads? You know, these can have like real implications for the cost of getting the job done. And I think really the best case is to have like a really well integrated, well gelled team of designers and developers working together in the trenches. So MVP, again, we want to create an environment where expediency and efficiency are shared high-level goals. And like this is, you know, kind of in a lot of ways incumbent on the business, I think. But if we want to ingratiate ourselves to that, and I think we all do from time to time, we should probably be banging that drum. You know, at a high level, what does the user need to be able to achieve for the business to meet the business goals? What are the buttons that they're going to be required to have on there, and where do those? What do they do, and where are they? And how do the high-level components of the app fit together? And then you hear this pixel perfect from time to time. That's like a bad word in my shop. Focus on flow perfect. That you can actually achieve. I like to say, like, the only thing that's pixel perfect is the app that you shipped. The mocks and the designs and the comps, like, if we're trying to get pixel perfect app with regard to comps, I think we're going to be off the rails. So from a process standpoint, you know, one way or another, again, the designers need to feel the relative complexity costs between the design decisions that they can make. And if for whatever reason they can't weigh those implementation costs, they can't be expected to make good decisions for the product. And if for whatever reason engineering can't communicate about implementation costs ahead of incurring them, then we have no idea how much things will cost or how long they'll take. And I think really these are kind of equivalent statements. As a team, we need to be able to weigh the costs of our decisions around product in order to operate efficiently. Okay, recap. Mobile is hard. It ain't like web apps. Write automated tests where it makes sense. Use a manual test plan for verifying visuals and integration with all the real-world services. And we do this kind of like iterating between design and development and good feedback loop there to make sure that we're not fighting the platform. Whew. All right, this is where I take a glass of water. All right. So we talked about mobile being hard, and I don't think I've fully made that case. I'm going to try and just kind of point at the moon here a little bit. Here's a crazy idea. I think UI code is just basically configuration. UI code essentially emits an ad hoc, denormalized blob of a data structure with embedded behavior that's then fed to what I call the system. And the system applies a bunch of crazy heuristics in an attempt to interpret that data structure and to display something meaningful to the user. Who could be using a screen of any size? Who knows like what browser? They might be using a screen reader. Who knows like what they're actually going to be looking at. And this is really the same for mobile and the web, or any system where you're doing UI stuff. UI code, it's kind of just configuration. It rarely encodes logic in the usual sense of the word. Like there's definitely not like when an order comes in, you know, print an invoice kind of logic. It's sort of, we're making this tree of objects that we're just hoping is going to result in like the pixels that we think are the right ones. UI code can be really expensive to modify. I like to say around the shop, you know, these views are write once, read never. Especially if you're using Interface Builder on iOS, the files that thing generates are completely inscrutable. You can't really read them. God help you if you're trying to look at a diff and do any code review with an Interface Builder file. And when the engineers put these things down, they're going to basically forget how they work almost immediately. And in order to pick them up again, you know, I think honestly the cost of trying to figure out like a really complex piece of UI code that involves like controllers talking to views and like all sorts of crazy stuff is on the order of throwing it out and rewriting it. Just a crazy idea. So this is why I recommend doing a manual test plan. Don't try and innovate with regard to UI code. Just do what the system wants you to do. You know, don't wrestle with the pig. You both get dirty, and only the pig enjoys it. So what are the realities, though? Inevitably, the design folks are going to want that button or field or checkbox or form or whatever to look that special way, and they're eventually going to get their way. And if you don't do it, there's a queue of other developers out the door who will, and they're probably going to do it wrong. So what can we do? Here's an idea. Develop a palette of components, like sort of, you know, whatever side of the table you're on here, like let's think about saying like, we're going to define our toolbox. We need like rather than like a red button, we need a destructive action button. And we're going to use destructive action button in all these different places. And you can just go on from there, right? There's like the confirmation action, the sort of like, you know. And if you look at what Apple has, for example, in like that like little corner palette thing in Xcode, there's just like a lot of components that just look the same. And they kind of have the same semantic meaning. So when we're trying to make that really pretty, like glitzy user experience, let's do it from the perspective of we're trying to like build a palette of widgetry and kind of have like a library of things that we can reuse. And you know, when the UX people want to change this, that's the code change gets made in one spot, propagates throughout the app, and it keeps the app visually consistent with itself. You're kind of like making a design language almost when you're reusing a palette of components. And we really want to, this was something that kind of bit us pretty hard at some point. Avoid like new ad hoc designs for like every screen or workflow that comes through. You really want to like have a palette and leverage it. Because if it's like a completely new design for like this corner case of onboarding or this particular customer or whatever, that work is really hard to estimate and it tends to just be really costly, especially if we can't leverage anything that we've already built. And again, collaboration between design and development is key. Remember that it's really easy for the designer to underspecify, the developer to make some assumptions, neither of them realize it, and lead to disappointment and frustration. Too much time spent iterating on like relatively low business value minutia, and at some point we've got this like political and organizational cost that we got to wrestle with. Like people might be disgruntled, like the product ship date slipped or whatever, and like we all have to do the emotional work to get happy and productive again. We want to avoid incurring those costs as much as possible. So again, get designers and developers in the trench together, get them collaborating, understanding each other's needs and what it takes to get the job done from either perspective. Concentrate on flow perfect, never pixel perfect, and really focus on business value. So where are we? Mobile is hard. Test what you can, visually inspect the rest. UI code is hard to reason about. Don't fight the system, and focus on business value. Okay, a little bit more about deployment. Let's compare web apps again here. I think there's a lot of like just works kind of deployment tools. There's a lot of well-established methodologies and widely practiced orthodoxies with regard to all this stuff. We've got Capistrano, Fabric, Heroku, Tomcat, all of these things that amount to put the files on the server and bam, your app's running. For mobile, we don't really have this. There's just a lot more going on. We've got code signing, which is kind of constantly breaking. It's sort of devs just see it as a hurdle. There's lots of clicking and inscrutable error messages that crop up. Half the time it's broken, you fix it, you don't know what you did to fix it. You just cross your fingers that it's not going to happen again. It can be really tedious. There's like clicking through all those IDE dialogues in Xcode or Android Studio. And then once you've made that signed build package, you have to like go log into this web app and like upload this thing, which includes a lot of like manual clicking. And then those web apps are constantly changing. Like this one time, they updated iTunes Connect, and I had like just dragged the IPA package up there and like changed the metadata and thought that that was it. Well, it turns out they added like a save button, and I had to click that save button. But I had told my client, oh yeah, the build's gone out, like we're good. And then 24 hours later, they're like, where is it? And I was like, oops, I didn't click the new save button. So this is scary stuff. Not to mention all the icons, the screenshots, the other assets that have to be generated, release notes, crazy. And then you got the code review, or the Apple iTunes review process, which just serves to make deployments really high stakes, right? It's time consuming to get it in there with all those assets. That's expensive, and then it's really scary because there's like this fear of rejection. And all these things conspire to make deploying to the App Store just like less frequent because it's just, there's a lot of emotional weight there. And I'm gonna make the same point Tom did, like just start scripting stuff. Like it doesn't matter, like find that command that builds the app. You just gotta start doing automation at some point. Find the command that runs the tests, find the command that like builds that IPA package even if it's not code signed yet, or APK, whatever. And then do the incantations to get the code signing, and eventually you're going to get all this stuff, and sort of like way down the end, you're going to have like a system for automatically generating your icons in all the million billion sizes that Apple and iTunes and Google want. You can even do like some sort of system where your app like boots up, takes a screenshot of itself, and it emits all the screenshots in an automated fashion, so all of your UI updates are updated. And eventually you're going to get to the point where you have like everything you need to go to the App Store just like in a directory after you ran your build. And it's going to be great, but you just have to start doing it. And then it's funny how many of these points Tom has already made. Just like the goal is to get into CI and use that to exercise all of this regularly. And I'm going to assume that most people know what CI is. The idea is that just like anytime you commit something and push it up your repository, the CI server checks it out, runs the whole build, generates everything, and if anything broke, any of the tests failed, if anything doesn't compile, then it throws up a big red X and screams at you and like emails your boss and stuff. So another like kind of low value side point about CI, don't outsource it, just get a Mac Mini off of Craigslist, download Jenkins, run it, click through the project setup and be off to the races. There's a lot of CI as a service startups out there, and there's just nothing differentiating them. They're going to be way slower than any kind of dedicated box you could have in your office. They're constantly doing stuff like redeploying their own environments, updating their VMs or whatever. This can cause build breakage for you that you're not going to understand why it happened. Like you could run the build on one commit, one day it passes, they do something, run that same build on that same commit, it's broken. You just never want to spend time thinking about this. So just don't outsource CI. And the other thing is that at the end of the day, like you're trying to make a signed build, and you want to do that on a continuous integration kind of basis, and like you definitely don't want to upload your private keys to this crazy startup that might not be around in like a year or whatever. So just build out your own CI server. Don't use CodeShip or anything like that. Which takes us on to the next crazy principle where it's just me start raving mad in the hallway. Write your own everything. This is probably a low value point, but the idea is like own and maintain your tools. Your team's going to know how it works. They're going to be able to maintain it. Be really, really careful about taking dependencies on open source projects. When the developer who wrote that gets bored and abandons it, like you're going to be stuck. Who knows, like when they're changing it, like what dependencies they add, what dependencies their dependencies add. At some point you have this like, you've pulled in all of NPM into your build server and you only need like 2% of it. And if any of it breaks, you just have no idea what happened. And like really the thing is like no one can anticipate your needs. Your needs are super unique. So address them, take responsibility for that, and invest in your own experience as a team. And that goes back to like the whole like just start writing a script that like does these things. You're going to need to do it anyway, and when it breaks, you'll know in CI, and then you can fix it. Another kind of low value point, but the idea here again is to like drive down the emotional costs of deployment, which I feel like are really high for mobile relative to web apps. It's predicated on having on frequent builds that are coming out of your CI server, but the idea is like as soon as a build is approved by Apple or Google or whomever, just turn around and submit a new one because you have a good one sitting in your CI pipeline anyway. Just because they approve a submitted build doesn't mean it has to go to production. You can always just enable that manual release flag so that you have ultimate control of what is going to production and when that's happening. But again, like whatever we can do to like drive down the technical, emotional, and organizational costs of emitting a build and getting it into at least sort of like in the chamber and ready to go to users when we pull the trigger, that's a win. All right, so this is getting to the bitter end here. The bottom line, test coverage, automated and manual, preaching to the choir on that point. Minimize UI complexity. We want as little code as possible. We want to reuse as much code as possible and really engender that feedback loop between design and development. And then invest in automation. Just start automating stuff. Deployment, CI, building, testing, all those things, asset generation. You can do it. It's possible. I've seen it. And what do we get out of this? We're confident. We've minimized complexity where it hurts the most, which is the UI. And then we're running manual QA on that. For everything else, we've got automated tests. We can build at any time, which is great because we can get our stakeholders sort of the latest and greatest without worrying too much about are they finding bugs. Again, we're trying to drive down that emotional cost of oh, it's release day. Every day is release day. Just go for it. And that's going to allow us to have a more predictable and stable release cadence. So that's the end. Any questions? Heckling?
Just to give a +1 to designers and developers and QA and the whole sitting together and being together, because that's what DevOps is all about, is breaking down the silos, and it certainly doesn't work when everybody's looking out for their own interests.
Yeah, definitely. And something that probably I don't know, if you're feeling what is this crazy guy up here talking about? I have never really worked with a dedicated QA organization. Like it's usually either the developers or the stakeholders like doing the manual test plan. So that's like kind of where some of these ideas about like put it in source code control like come from. So it's everyone's kind of like got their hands dirty. Again, like we work with a lot of startups, so everything's pretty scrappy. But yeah, it really is about getting everyone together.
Can you give us an example of a backend module that you're talking about?
Yeah. Okay. So like let's imagine like a really basic app that's just like a conference calendar. Like, okay, you're at this conference. I actually haven't downloaded the app, but I imagine that there's probably just a schedule of events, and like you go to it and it shows you the schedule of events. So what would go in the backend module for that really simple app? Probably something like the API client, so all the code that talks to the server that like logs you in and downloads that list of stuff. All the model objects, so like we probably have like an event model, and then like if there's any other, what else would a really simple app like that do? It's something that probably wouldn't go in that module. Obviously, would be like all the view controllers and the table cells. That would be in the front end module where that's like sort of covered by manual testing. And then if it has something like tweet that I was here, that's kind of on the fence, right? Like maybe if tweet that I was here is just like an API call to some service that doesn't have any UI other than a button that's just like go. Maybe that goes in the back end, or if it pops up like a dialogue, or it depends on like the Twitter SDK or something like that, probably goes in the front end. But it's really just about like being really disciplined about like, can I write this code in such a way that I can compile this file without having a dependency on Android.view package or UIKit framework? Like, be smart about like, can I take even this like 2 lines of code and put it over here where I can compile it without reference to any kind of UI stuff? So like API clients and model objects are obvious, right?
So just to follow up.
Sure.
Do you have any strategies for testing push notifications? Because that's something that I struggle with.
Yeah, so that's kind of like, well, it's going to be really expensive and you're going to mess it up. So first accept that. A couple of things that I brought up in the talk that directly relate to that. One, mocking things out. So like that dialogue about getting push notifications to come up, like the first thing you should do is make some sort of like fake system that doesn't actually, so you can present that dialogue and run through the user experience without actually touching the push notification system, because it's going to be really hard to get that dialogue to come back, like I said, without doing a factory reset on the device. Secondly, like whatever you're using notifications for, if it's something more rich than like Jimmy just like liked you on Facebook and it just tells you that, like if it's something like the app needs to get this data and react to it, it's pretty easy to kind of mock that out, right? Like somewhere in your app you have an interface that's like, this gets called whenever the notification comes in, and like it processes the data in some way. You can do that without taking a dependency. You can write all that logic without taking a dependency on the push notification thing, and then just like in your automated test, cram a notification shaped object into that API and assert that it does the right thing. So actually push notifications is a good example for the state machine thing too, because there's kind of like a lot of steps to that. Like you're probably going to want to say like, hey user, like do you want push notifications? Like here's why, I'm going to sell you on it. And then you're actually going to present the system dialog if they say yes to that. And then there's like this dance where it like goes out and like gets a token, and then you have to like send it back to your backend service, and then you get like some other thing probably from your backend in exchange for that. And then like later you might get a notification that's like a 2-factor auth or something. You can see there's like the sequence of events that has to happen. That's like a really good application for the state machine thing, because you like the user did whatever, and so the side effect is present them the do you want the push notifications dialog. If they say yes, then present the system dialog, and if they say yes, like do whatever. But then there's all these cases where they might have said no here and we do something else, or if they said no at this step, then we do something else. And then like if the system failed to get a token for whatever reason, God help us, like we need to display an error. And you can model all these as like input events and then like output side effects. And a state machine is like a really good way to do this. And you can just write automated tests around all of it. And it doesn't depend on UI, it doesn't depend on the actual notification service. Way in the back.
So
You know, there's always, I kind of feel like there's sort of a flavor of the week there. Like I feel like someone sent me some like InVision mock-ups or something like that. Yeah. I'm like, I've seen so many of these tools come and go that I'm just sort of like, okay, tool, like I'm great. Like you can draw stuff with a thing, but like what you really need to do is focus on the conversation. Like, you know, wireframes are really great because like, you know, particularly if they have squiggly lines and things because stakeholders see them and they realize immediately, oh, this isn't exactly what it's going to look like. And so this kind of, you know, we talk about levels of fidelity in design. Like Sketch is like, it tends to result in like really high fidelity mocks, right? And it's easy, you know, something like Balsamic, I think, is like the wireframing tool right now that makes the squiggly lines. Like you just need to make sure that expectations are kind of like calibrated realistically around how the work is actually going to get done. On the one hand, you have wireframes where it's like, no, like this is just like, we're just kind of sketching out like what it would look like. On the other hand, there's like Sketch or Photoshop where it's like, no, it's really like gonna look like this. Like these Nike designers like put it together, like look at the swoosh, it looks awesome. You know, it's like pictures of people running. As long as like everyone is bought in on like, okay, these comps are like kind of a touch point and they're more about, they're like a communication tool between design and development than they are like a reification of like the product that's actually going to get shipped. Remember, you're shipping software, not sketch files. And yeah, I don't know if that addresses your question. But it's just kind of more about the conversation and trying to like, so like Sketch has like these reusable components which are really great. And I've seen some designers, like a guy came into our office just yesterday and had like essentially what were wireframes, but he could change, you know, like the shopping cart icon to either have like a thing in it or be empty. And he had like this whole reusable thing. Like he flew through Sketch and I was like, dude, that's amazing. Like I wish I had the patience to do this, but I would probably just start writing code instead.
Okay. Time's up.
All right.
Thank you.
Thank you.